All right, hello and welcome everybody to another physics video lecture. Today we are going to be talking about inelastic collisions. All right, so a little closer. So again, whenever we're talking about collisions, what we're talking about is exactly what you saw here. We're talking about things smashing together. In order to understand how things smash together, we got to understand this concept of momentum. All right, so you're going to hear me talking about this a lot. And momentum is one of the simplest concepts that we see all year. Momentum is mass in motion. That's it. To find momentum, all you have to do is take the mass of the object and multiply it by its velocity. Okay? We use P for momentum, but we're not really worried about the variable today. We're worried about this. We are concerned with this, right? You take the mass of the object, multiply it by its velocity, and you find its momentum. The bigger the momentum, the more difficult it is to stop that object. All right? Now, last class we saw that there is a law of conservation of momentum. And what that means is very simple. It means that no matter what happens, momentum is always conserved. And all that means, if something is conserved, it's saved. Meaning the momentum you have before the collision is going to be equal to the total momentum you have after the collision, okay? The pieces that are banging together, all right, their velocities might change, but the total momentum always stays the same. The momentum before is equal to the momentum after. Now, last class, we saw elastic collisions, okay? And again, whenever you see elastic, I always like to think of a rubber ball. Rubber balls bounce, and that's what happens in an elastic collision. Okay, the objects hit each other and then they bounce off. So what this means is it means that before they collide, okay, you have the momentum of the first object and the momentum of the second object. They're separate. They both have separate masses. They both have their own initial velocities. After they hit each other, they bounce, so they're still separate. Okay, they both have separate masses and they both have separate final velocities, right? We saw in last class that momentum is always conserved, but with elastic collisions, kinetic energy is also conserved because they're hitting each other and bouncing off, meaning that they have kinetic energy, the energy of movement, and then when they bounce off, they are both still moving, so you have kinetic energy turning into kinetic energy. And again, the best example would either be pool balls bouncing off of each other, or if you've ever seen one of these are called Newton balls, and they show objects bouncing and momentum staying conserved. So today, we're going to talk about inelastic collisions, okay? If you've never seen the prefix in before, in means not, right? If something is incomplete, it is not complete. If something is incorrect, okay, it is not correct, all right? So inelastic just means not elastic. So instead of being elastic and bouncing off of each other, in an inelastic collision, the objects stick together, meaning that before they hit each other, okay, their momentums are separate. Each object, okay, has its own mass and its own initial velocity, all right? And to find the total momentum before, you just add them together. The difference here is that afterwards, because they stick together, okay, they're no longer two separate objects. They are now one object that is stuck together, all right? So their masses are now combined. So you take the mass of the first object and add it to the mass of the second object, right? So they start off separate and they stick together, okay? So now they have one mass, which is their old mass is added up, and they have one singular final velocity. Why one velocity? Well, because they're stuck together. So they're only one mass, okay? Because this is an inelastic collision, and because they stick together, okay, even though their momentum is conserved, their kinetic energy is not conserved. That kinetic energy goes into changing their physical shapes and bending around each other. So kinetic energy is not conserved, only momentum. An example of this, which you will see again and again, are the unfortunate car crashes. Two cars hit each other, their shapes bend, they entwine, and they become one big mass, all right? So here, again, if you want to go through this on your version of the PowerPoint, you can see the car and the truck. The car has a mass of 1,000 kilograms, and its velocity is -10, okay? Well, actually, I'm sorry. Its velocity starts off as 20 meters per second because it's going in the positive direction, whereas the velocity of the truck starts off -20 because it's going in the opposite direction or the negative direction. This is very important to see, okay? So another thing to remember is that if going to the left is a positive velocity, then going to the right is a negative velocity, all right? When they combine, they stick together, and you can see that their momentums become one. They become added together. All right, so let's look at this. So again, this is what our equation for today looks like, our inelastic collision equation. The two objects stick together. They are separate before the collision, and they are together after the collision. So again, we have our equation here. The first part looks exactly the same. We have the momentum of the first object, m1 v1 initial, the mass and velocity of the first object, plus we're adding it to the mass and the initial velocity of the second object. That's going to equal the total momentum after, right? The total momentum before equals the momentum after. And here we add the two masses together and multiply it by its single velocity. One mass, one big mass has one velocity. Again, I give you the list of all of the variables. Oh, you can see them right here, okay? I've included that m1 plus m2 is the two masses combined, and let you know that vf is the final velocity, which is both objects combined, just to help you out. All right, so let's dive in and let's do some problems. Okay, so in increasing order of complexity, let's start with some football players tackling each other, okay? So, start off by writing down everything you know. The first thing we know is we have a 90-kilogram football player. So we're gonna, whichever mass you get first, I call that M1, right? M1 is 90 kilograms. And he is moving, or she is moving at an initial speed of 5 meters per second. So that means V1I is equal to 5 meters per second. All right? M1, V1 initial. This football player tackles a 110 kilogram football player. So that's M2 equals 110 kilograms, who is at rest, meaning that the initial velocity, V2I, is equal to 0 meters per second. This player is at rest, so they are not moving. What is their final velocity? Now, I don't like to write too much here because it gets smushed, but obviously they stick together, right? They're tackling, they're holding on to each other. So even though they're not combined forever, they're holding on to each other. So we're gonna consider them one mass, meaning they're gonna have one final velocity. And that's what we're looking for. Step 2, write down your equation. We have M1 V1I plus M2 V2I equals M1 plus M2 times the final velocity. They're separate before and stuck together after. So plug your numbers in. M1 is 90 times their initial velocity, which is 5, plus M2, which is 110, times their initial velocity, which is 0, which equals their masses combined, which is 90, plus 110 times the final velocity. Now you know you're on the right track because we only have one variable here, which is great. We got that VF. So we're trying to get that bad boy by itself. Before we can do that, we need to do all of our regular math. All right, so step 1, we have 90 times 5. I can go to my calculator. There we go. There she is. Okay. Okay, sorry, it's kind of hard to see down here, but I'm going to go 90 times 5. We're going to enter answer, and that gives me 450. So 90 times 5 gives me 450. All right. I'm going to get rid of the calculator for just a second because I have 110 times 0. And guess what? Anything times 0 is 0, right? Now, notice I'm doing all of my multiplication before I do any of my addition. Why? PEMDAS, parentheses, exponents, multiplication. It's also why I put parentheses around these, so to remind myself to do that first. So for this side of the equation, 90 times 5 is 450, plus 110 times 0, which is 0. Anything plus 0 is itself. So that's that side of the equation. The other side, I have 90 plus 110. 90 plus 110 is 200. We're doing that first, and then we're going to multiply that by V2F. Hopefully, you are starting to see a familiar pattern. We got V2F. We want to get this by itself. This is multiplication. We want to move that 200, so we're going to divide by 200, and we're going to do that to both sides. So I have 200 divided by 200 is 1. I go back over here. I have 450, and I'm going to divide that by 200. And that gives me my answer, which is way over there, so I'm going to bring it over here, which is 2.25. So here, my final velocity is 2.25 meters per second. Now, let's notice a few things, okay? One football player was moving in the positive direction, and they hit a standing football player who was not moving at all. The resulting velocity, this velocity is positive, and this velocity is positive, which means that those velocities are going in the same direction. This guy's running at 5 meters per second, hits the big guy, slows down, is now moving 2.25 meters per second, but is still moving forward, still moving in whatever the positive direction is. Okay? All right, you good? Okay. So let's take this and just ramp it up just a little bit. Let's make it a little harder. Same topic, we're looking at the same two football players. Let's read through and see where it's different. We have a 90 kilogram football player, all right, same, M1, 90 kilograms. Moving at 5 meters per second, V1I, 5 meters per second. Tackles a 100 kilogram player, okay, 110 kilograms, okay. Who is moving at 3 meters per second in the opposite direction? Very important. So now our second football player has its own velocity, their own velocity. So V2I is now equal to negative 3 meters per second. Why is this negative? It doesn't say negative here. Well, because they're going in the opposite direction. Meaning football player number 1 is coming in this way, football player number 2 is coming in this way. One velocity is positive, one velocity is negative. And to be honest with you, I always just say whoever's first gets to be positive. That's the way I do it. Makes it easy. Again, we're looking for their final velocities. Okay, so now we're looking for VF. Pause the video, see if you can solve it. Did you get an answer? Let's see if you're right. All right, so we got M1 V1I. Excuse me. VF. Okay. Start off separate, end up together. Let's plug our numbers in. Our M1 times V1I is going to be 90 times 5. Now this time we have 110 times velocity here, which is negative 3. That's going to equal mass 1, which is 90, plus mass 2, which is 110, times V final. All right, same old soup, just reheated. We want that VF by itself. But let's see how this is now changed, okay? We still have 90 times 5, so this is still going to be 450. But now we have this as 110 times negative 3, which is not positive, is now negative 330. 110 times negative 3 is negative 330. So you could say plus negative 330, but adding a negative is the same as subtracting. You with me? Good. This side looks the same. We have 90 plus 110, which is 200, times VF. I'm going to go ahead and do this math right here. 450 minus 330 is actually 120. 200. All right. In case I lost you, let's go back to the old calculator. think you guys get this, but let's make sure. Okay, so I'm gonna clear this, and I'm gonna go 450 minus 330. Boom, answer. That gives me 120, okay. And again, we got VF, that's what we're looking for. I gotta move this 200, this is multiplication. So I divide this side by 200. Whatever I do to this side, I do to this side. 200 divided by 200 moves 1. And now I go back up here and I got 120 divided by 200. Answer, which is way over here, so I just say answer so you can see it, which gives me my answer, which is VF is equal to 0.6 meters per second. Now, notice the difference. In the first example, we had a bigger final velocity, and that's because player 1 was just hitting the player at rest. Now, player 2 is also moving in the opposite direction. And because of that, their total velocity is going to be smaller. But the total velocity is positive. And because of that, we know that they're still moving in the same direction as that first player, because we said the 90 kilogram player is positive and the 110 player was negative, right? Positive, negative. This velocity is positive, so we're still moving in that positive direction. You with me? Go ahead, make sure you get it. Sorry about the kind of smudgy marker. I think it's still a good one though. I hate throwing away markers before they've lived a full life, you know? I like to give the markers a chance to live their best life. So we're riding this one through. All right, last but not least, we have trucks and cars smashing into each other. Let's see how to do this. We have a 4,000 kilogram truck. So mass 1 is 4,000 kg. You know what? Why don't you pause the video here and see if you can solve this one by yourself. Did you get an answer? Let's check. 4,000 kilogram truck is moving at 20 meters per second. So V1 initial is 20 meters per second. That is the initial velocity of the truck, which we're calling M1. The two vehicles, okay, it crashes into a 2,000 kilogram car. So we're gonna say that the car, M2, is 2,000 kilograms, okay? The two vehicles stick together and have a final velocity of 10 meters per second. All right, so they stick together and we know the final velocity is 10 meters per second. What was the initial velocity of the car? So we're looking for V2 initial. Remember, the car is the second vehicle, and we're looking for that initial velocity. If you're looking at this picture, kind of flip this. I am saying that the truck is going in the positive direction, and the car was going in the negative direction, okay? So if you're looking at that and you're like, why is it positive? Flip that around, okay? All right, let's write down our equation. It is M1, V1I, plus M2, V2I equals the combined masses times their final velocity together. M1 is 4,000. Its initial velocity is 20. Plus M2 is 2,000 times its initial velocity, V2I, which is what we're looking for. That equals 4,000 M1 plus 2,000 M2 times the final velocity, which is 10. Everybody see how I did that? M1 plus M2. The initial mass, the mass number 1 and its initial velocity, mass 2 is 2,000, and we don't know its initial velocity. So now this time, we're actually looking for this variable right here. All right, so how do we do that? Well, math is the correct answer. So here we go. Let's go to the old calculator to make sure I don't make any silly mistakes. Kaboom, kaboom. Clear all this out. All right, step 1. We have 4,000 times 2,000. If you can guess, 4,000 times 20. In your brain, what did you get as an answer? Did you get 80,000? Because if you did, good job. So here we have 80,000 plus 2,000 times V2I, parentheses around that. That equals 4,000 plus 2,000, which again, just for the sake of being clear, 4,000 plus 2,000, hopefully you know, is 6,000. And we're going to multiply that by 10. Remember, you do what's in the parentheses first and then do the multiplication. So we're going to multiply this by 10, and hopefully you know. No, I want to do this. Oh no! Here, let me just clear this out. I remember the number. So I got 6,000 times 10, and we're going to go enter and answer, and that gives me my answer there. So this side of the equation is 60,000. Now, this next step is very important. You can't add these two numbers together. Why not? Because this one is being multiplied by V2I. All right, so even though they're big and it looks like you want to have them together, you can't do that because this is being multiplied and it's PEMDAS. You can't do it. So the first thing you got to do is you got to move this 80,000. All right, so to get rid of this, 80,000 is being added to this. So to get rid of it, we have to subtract it. And whatever we do to this side, we have to do to this side. All right, 80,000 minus 80,000 is 0. And we have 60,000 minus 80,000, which why not put it up here? Minus 80, 1, 2, 3, 4, equals, oh, I can't hit that equals. I put it too far over. Equals, answer, negative 20,000. Very important. So now look at what we got. Now I have 2,000 times V2 initial is equal to negative 20,000. All right? That negative is going to be super important. So what do? Well, we want to get V2I by itself. This is multiplication, so we're going to divide this side by 2,000 and this side by 2,000. 2,000 divided by 2,000 cancels. And if I go over here, I got negative 20,000 divided by 2,000. Enter. Answer. Gives me negative 10. I'll put that over here. Here you go. V1I is negative 10 meters per second. I just put it right here. There's your answer. Now, notice our answer is negative. What does that mean? Well, if we look at the problem here, the truck was moving in the positive direction, okay, because it has a positive velocity, and the car was moving in the negative direction, because it has a negative velocity, okay? When they hit, the truck was much bigger and had much more momentum, so their final velocity was positive, meaning the truck is bigger, so it's going to keep moving, just like we saw here. Right here. Here, do you need me to go back? I don't want to delete this till you're done. If you need that, pause it. You good? Did you get negative 10? You did, good job. All right. You can get that. Remember, you can always pause the video. You can always slow me down. There's that slow down button. So look at this. Here, the car starts off with a positive velocity, and the truck starts off with negative. Positive 20, negative 20. Because the truck is bigger and has more momentum, when they finish, both of them have a negative velocity of negative 10. Their velocities are combined. All right? All right. Well, hopefully that answers all questions about inelastic collisions. Remember, the two objects start off separate. You add their momentums to get the total momentum, but they stick together when they hit, so their masses are combined, and they only have one final velocity. Only momentum is concerned. Examples are like car crashes or two football players hitting each other. If they're moving in opposite directions, one velocity is positive, the other velocity is negative. And Bob's your uncle. That should do it for you. All right, guys, if you have any questions about anything, you can email me whenever you need to, or find me on Zoom for tutoring after school. Have a beautiful day.